This video is on tree diagrams. Tree diagrams, in a previous video I explained that it is used to help us organize multiple bits of information so that we can come up with the probability of things happening when you have multiple events happening, and it's just to really keep us organized. So this example says Tina's favorite meal is pasta followed by ice cream. Tina's mom cooks pasta once a week. If she cooks pasta, the probability Tina gets ice cream is 2 out of 3. If there is not pasta, the probability of ice cream is 1 out of 4. What's the probability Tina gets ice cream? So we have two events actually happening. We have she's either going to have pasta or she's not going to have pasta. And then the second set will be she's going to get ice cream or she's not going to get ice cream. So it's those two possibilities happening. So we're going to start off with our little starting point. And the first thing is she's either going to have pasta or she's not. So we're going to have the first branch is going to have pasta or no pasta. Then, once we figure out if she's having pasta or no pasta, she can either have ice cream or she won't have ice cream. So from the pastas, we'll go to ice cream or no ice cream. Ice cream or no ice cream. So same thing, if she does not have pasta, she still has a chance of getting ice cream. But then she also has a chance of not getting ice cream. So figuring out our sets, we would say pasta and ice cream. So I will go with P and then I. For pasta and no ice cream, I'll do P and then NI for no ice cream. For no pasta then ice cream, I'll use NP and then I. And then for no pasta and no ice cream, I'll use NP and then NI, just to represent those values. So then we can get our fractions for, we need to use our numbers in here in the information to figure out our probability of it happening. So it says that Tina's mom cooks pasta once a week. So pasta would be once a week. Now there are 7 days in a week, so we would put 1 out of 7. So then for no pasta, we would have to have 6 out of 7. Then if she cooks pasta, so from here, these two branches, the probability Tina gets ice cream is 2 out of 3. So we'd have 2 out of 3 for ice cream. Therefore, we'd have to have 1 out of 3 for no ice cream. Because again, each set of branches have to add up to 1. If there is not pasta, so we follow this set, the probability of ice cream would be 1 out of 4. So then the chance of not getting ice cream would be 3 out of 4. Now that we have our numbers, our probability on our tree diagram, we can put our actual probability off to the side of pasta and ice cream, pasta, no ice cream, so forth and so on. So we're going to multiply these. So we have a 2 out of 21. 2 out of 21. Okay, that is a 2, not a 20. I will write that out. 2 out of 21. And then for pasta, no ice cream, that would be 1 out of 21, because 107 times 1 out of 3 is 1 out of 21. No pasta and still have ice cream would be, that's 6 over 28. And then no pasta, no ice cream would be 18 out of 28. Now these denominators did change because the chance of it happening here changed from this one. And that's okay because we're still dealing with fractions and we can still add and subtract when we need to. So the question is asking what's the probability Tina gets ice cream. So we want ice cream, so this is a chance where she can get ice cream. So we want probability that Tina gets ice cream. We want the ice cream, so we follow this path. And we again want ice cream, so we follow this path. So our two values are that 2 out of 21 and that 6 out of 28. So 2 out of 21 plus 6 out of 28. And we can add that. So 2 out of 21 plus 6 out of 28 as a fraction is 13 out of 42. 13 out of 42. Now we do want the probability of this happening, so 13 out of 42 is approximately 0. It is, for 3 significant figures, we have a 3095, so that 5 makes that 9 go to a 10, so this would be rounded to a 0.310. So even if she doesn't get pasta, she still has a chance of getting ice cream. With no pasta, she has a 6 out of 28 chance of getting ice cream. But when she does eat pasta, she'll have 2 out of 3 chances of getting ice cream if she eats pasta. So the chance that she's going to actually get to do that is 2 out of 21 and then 6 out of 28. So the chance that she'll get ice cream will be 0.310. On this next example, it says the probability of a fine day is 3 out of 7, while the probability of a wet day is 4 out of 7. So we have a fine day and a wet day, so that's 2 branches. If it is a fine day, Joe goes to work by bike, drives, or train. So now, instead of having, here we've had two branches coming off the starting point, which we will still have. We'll have a fine day and a wet day. But then from each of our first event, we only had 2 branches coming off of it. This time, we'll have 3 different branches coming off of it. So our tree gets a little different. So we're still going to have our starting point. We're going to have a fine day or a wet day. Fine day or a wet day. I'll go and put the numbers in just a moment. But then we have bike, drives, and train. And then if it's a wet day, also bike, drives, and train. So we have 3 branches coming off of each of these. So bike, drives, or train. I'll put bike, drives, train, bike, drives, train. So again, we can still do our sets. I'll use F and W for fine and wet, B, D, and T. So for this one, we'd have FB, then FD, then FT. Next one, we'd have WB, then WD, and then WT. So those are all of our sets. So now let's go put our numbers in. So the probability of a fine day, so fine day would be 3 out of 7. And then wet day would be 4 out of 7, which makes sense, because 3 plus 4 is 7. So then if it is a fine day, so we're going to focus on here, he gets to work by bike 7 out of 10, so we'll put 7 out of 10 here. Drives would be 2 out of 10, and then train would be 1 out of 10. So 7 plus 2 plus 1 is 10, so that one works. If it is a wet day, so coming down here, gets to work by bike 1 out of 9. Drives is 5 out of 9. And train is 3 out of 9. So 3 plus 5 plus 1 is 9 out of 9 is a whole. So that is good. So now we can actually find the information we need. So we have so many of them. And before we found all of the values. So let's go and actually look what the question is asking. What's the probability that Joe takes the train? So that's the one we focus on, the train. So if it has a train in it, we follow that one. So here's train. We're going to follow it back. Then we also have train here, which will follow it back. Those are the only 2 probabilities that I have to find for this problem because I only have that one question. So for this one, on a fine day for the train, the probability that this will happen will be a 3 out of 70. And the probability that it will be a wet day and he takes the train will be a 12 out of 63. So when I figure this out, I add these 2 together. So we have 3 out of 70 plus 12 out of 63. And if we add these and simplify our fraction, we'll end up getting 7 out of 30 when we add them and simplify our fraction. So now we just want to get an approximation of the probability of this happening, of him taking the train at all, is 0.233. This is to 3 significant figures. So on this one, again, I didn't find every single probability because I only really needed to figure out what is probability that Joe takes the train. That's the only one I care about, is him taking the train. But I could have figured out how often does he drive, or how often does he not take the bike. I could have worded it like that as well. And I could have figured out all of the drives in train, all of the drives in train.